Hello class. Yeah, hope everybody's okay. Now turning back to another topic here, we are on topic 4, which is using materials. Now this topic here is together with the matter, but it's quite independent, because ideally that word matter also means materials. I think we said that at first. Yeah. Now that means we are still in matter, but of course in some other way, in a topic called using materials. Now we have seen that materials is basically almost everything that is around us. See, everything that you see has an importance or a use, not so? Everything around you has a use, however useless it looks. Even soil has a use, doesn't it? Sand has a use. This duster has a use. These books are useful. This phone is useful. Everything, this board is useful. That means everything is matter, and ideally everything are materials. That's very, very clear. That means when we are talking about materials, we are simply again talking about matter, but going further to say what are the uses. Now, in the start of this lesson, I will request you to mention some useful materials around you. Mention useful materials around us. I didn't give an outline of the subtopics, but under here, our subtopics, the first subtopic is common materials around us. 2, we're also going to look at categorizing these materials. Categorizing the materials. Is it a plastic? Is it glass? Yeah, those are the categories. Then we are going to see properties of various materials. Properties of materials and their uses and uses. Then we shall pick up what we call polymers. Polymers. Then disposing and recycling materials and recycling materials. And that will be the end. That's the end. Now we start with that first subtopic called common materials around us. Common materials around us. Common materials around us. Common materials around us. Now I'll request you to mention useful materials around us, probably 7 of them. In your groups, discuss out some useful materials that you have around you. Include those in the sitting room. Have you got 7 of them? Can I receive a presenter? Present those 7 materials as I note them down as follow. Water. Yeah, water. Soil.
Pens.
Yes. Pens. Chairs. Books. Air. Vehicles. etc. Yeah, thank you very, very much. These are some of the useful materials around us. Now, there are so many, but you've mentioned only a few. Now, let us categorize those materials with respect to the following. Categorizing materials. Categorize them as one. Categorize them as plastics. Which of those are plastics? Categorize them as glass. Which of those are glass? Categorize them as ceramics. Those made from clay. Ceramics. Concrete. Those that have a component of cement in them. Cement and sand in them. Can you categorize them in a short, just 5 minutes? Give some plastics here, some glass, Are you through with that? Would we have a presenter presenting to us the different categories? Is it all present that? Different groups? We have Juko present the various categories here.
Under plastics, we mentioned pens, plastic pens, plastic chairs, and tables, linear. Then under glass, we had the glass test tubes, glass beakers, glass cylinders. Under ceramics, we had pots, bricks, statics, electron press, that kind of stuff. Under concrete, we had walls, concrete floors. Under metals, we had mechanic tables, mechanic doors, windows, window panes.
Okay. Thank you very much, Juko Lemero. Now, under categorizing materials, we have seen that materials can be categorized in various forms. We can categorize them as plastics, and many plastics are around us. We have pens, chairs, but we didn't speak of plates at home. Plates, cups, not so. Water bottles. Then under glass, you said we have some test tubes, glass beakers. What of window glasses? Not so. Then under ceramics, we have pots, bricks, statues, etc. Concrete, we have walls made of concrete. We have floors made of concrete. Metals, we have some tables made of metals, some doors and windows. All those are different categories of materials. Now let us shift very fast to properties of each category here. Properties of materials and their uses. Properties of materials and their uses. Now, we are going to pick one by one. What are plastics? What are some of the properties that make them important? What is glass? What is glass made of? What are some of the properties of each? Now, let us try to pick up properties here of each category. Properties of materials. Properties of materials and their uses. And their uses. Now we shall start with, let us start with the most common one here. Now the properties we shall need to look at the strength. Is it strong? Ductility. We shall also look at what we call elasticity. Is it elastic? Then we shall look at, under strength, we shall also categorize it as hardness. Hardness. Then we shall, under ductility, we shall see malleability. Is it malleable? Is it malleable? Can it be changed into another shape? To be ductile or to be malleable is to be changeable into another shape. Now, speaking on, let us speak on, we start with plastics. Plastics. What are plastics? What's a plastic? Maybe we would define it through putting heat on a plastic. If you heat a plastic, what actually happens? If you heated a plastic water bottle, let me have one person comment on that. What happens to that plastic? Yes, Patience, what happens to heating a plastic? It will melt. It will melt. If it melts, can such a plastic be designed into something else? It can be designable. That means a plastic would be a substance which, when heated, can melt and can be reshaped. That's very, very right. Can melt and can be reshaped. That means plastics can melt. Are they elastic? Are they stiff?
Yes.
Okay. Okay. Now that means we've seen a plastic is a material which, when heated, undergoes melting and can be reshaped into other shapes. Clear? Are you together? Yes. A plastic is a material that can melt when heated and can undergo reshaping into other shapes. Now, plastics, we've seen that they can melt and can be reshaped. But we can have those plastics which are also, if you heat them, some just harden and are resistant to melting. That means we can have plastics which are high density plastics and low density plastics. Low density plastics, if you heat them, they easily melt. Then the high density plastics, if you heat them, they are resistant to melting. Like plastics like melamine, bakelite, some plates that you have at home there, if you heat them, they sound like glass. But it's not glass, it's a plastic, a hard plastic called melamine. You see that? That means plastics can melt, so can be reshaped. Then we can have those which are hard and resistant to melting. Therefore, for them you cannot reshape them. If a plastic can refuse to be reshaped because it refused to become soft on heating. Now, plastics have very many uses. In fact, many of our items at home are made of plastics. We've seen chairs here, plastic cups. Is that very, very right? And the plastic water bottles. Now, are plastics elastic? To be elastic is to be pulled apart and you regain back your original state. Is a plastic elastic? But plastics are not elastic. Are you very, very sure? Plastics are not. If you pull a water bottle, it can't be brought back. It just stretches forth, not so? Can plastics be, are they stiff? Stiff is to resist bending. Can you bend a plastic? Patience, can you bend a plastic?
Some.
You can bend, meaning plastics are not stiff because they can be bent. And you say that plastics are what? Are not elastic. Are they strong? Some are strong, some are not, like those melamine plates which are resistant to softening on heating. They are very, very strong. Some plastics can make glasses, like car windscreens. It's not actually, the car windscreen is not actually glass, because when you heat it inside there, looks as if there is a polythene what? Material. Now that is a plastic that made that kind of glass. Now let us shift very fast to glass here. Glass. That material called glass. Now, what do they make glass from? Anybody has ever known about making glass? Glass is made from three substances. We have sodium carbonate. It is mixed with calcium carbonate and then mixed with sand. That means glass is a mixture of calcium carbonate which at the industrial level is called limestone. That means glass is made from a mixture of sand, limestone, which is calcium carbonate, and sodium carbonate, which are mixed together, heated, they melt. Now when that mixture melts, it can be designed into any shape of glass they want. They can design glass to look in any form. Some are thick. That means after melting that mixture, you can design any type of glass of your choice. Now they can make glass look various colors by adding some other substances which they are chemically called oxides. See that? That to change the color, some look red. They are changed by adding some additional substances. Glasses carry various uses. You've seen some are used in making glass windows, glass plates, glass cups, many glass items around you. Now, leaving glass alone, we can go to ceramics. Ceramics are those materials made, or items made from clay. Now, clay is a special type of soil which can be molded. When you add water to it, water makes it soft and slippery. A substance is slippery if its molecules can slide over each other. If the particles in a substance are able to slide over each other, that makes clay slippery, because when you add water to clay, water causes the particles of clay to slide over each other. Now clay can be changed into ceramics by adding water, molding, then applying heat to that clay. When you fire clay, it becomes hard. Is that very, very right? Yeah. Now ceramics gives us various substances, various items like pots. Some bricks are made of clay. Statues are designed from clay. After you apply what? Some heat. Now clay has some special chemicals in it that are not found in other soils, like it contains aluminium, a chemical called aluminium oxide. Hear that? And it also has another chemical called silicon dioxide. Those two chemicals make clay very, very special from other soils. That's why it is able to be molded into other shapes. Now, leaving alone clay, we can go to concrete. Concrete. What's concrete? When we say concrete, we mean a mixture. Well, some of us always think that concrete is what? Is anything you see made of what? Anything made of cement. Let me hear from you also. What is concrete? Yes, I see Patience with the hand up.
Concrete is a mixture of stones.
Mixture of stones, sand, cement, which is used for building. Mixture of sand, cement, and stones. The stones, any stones, which type of stones are found in concrete? Concrete. You have said cement is found there, not so?
Yes.
Also find smaller stones, which are called what? Gravel. Then finally you find sand. Sand.
And then those are from just you must put water.
And water. Thank you very much. That means you can have concrete if you have those four things. Now, concrete is very hard, not so? What are some of the properties which make concrete be very, very preferred? Yes, let me hear from us, Paulo. Why do we like concrete very much, and where do we like it? Where is it like to do what?
Okay, concrete is preferred because it is, first of all, resistant to fire,
Fire.
resistant to harsh weather.
Mm.
And we use it like in building like maybe certain buildings.
Buildings. Okay, Patience, does something about concrete?
I think concrete is most preferred because it is made up of stones, and stones which are very hard, which cannot easily shatter.
Okay. It's hard, not so in simple terms. Yes. Now, okay. Could we simply summarize the properties of concrete in terms of this? In terms of strength, is concrete strong? To resist what to resist a force being applied to a material is what we call strength. You resist without breaking down. Concrete can resist many things. So is concrete ductile, or can it be designed into other shapes? It's only metals which are ductile or malleable. They can be bent into other shapes or drawn into other things. Is concrete elastic? It's not. You can't pull apart concrete, you just split it. Is concrete stiff? It is stiff. What of brittleness? Ability to break without bending is what we call brittleness, brittlity. Is concrete brittle? Can it break without allowing it to be bent? That means concrete is brittle. I think people need a clarity on some of these things. Brittlity. Strength is to resist bending or to resist breaking when a force has been applied to a material. Resisting breaking. Clear? Ductility is the ability to be drawn, to be made or shaped or made into wires, and it's only metals which can be made into wires. Elasticity, the ability to regain original shape when you have been stretched by force. Stiffness is the ability to resist being bent, to resist bending. Then brittlety is to break without bending. Clear? Now, going down to metals. Metals here. Metals. Our metals, we have them daily. Metals. Could we speak about some of the properties of metals? Are metals strong? Metals are strong. Are metals ductile? Yes, they can be made into wires. To be ability to be drawn into wires or made into wires is what we call ductility. Are metals elastic? They are not elastic. Are metals stiff? Do they resist bending? Metals are stiff. Some are stiff, some can be bent, of course. That metals can be stiff, some are not stiff. Are they brittle? Brittleness is to break without bending. They are not brittle. Brittlety is to glass. When glass is you hammer glass, what happens to it? It shatters. The glass undergoes what we call shattering. To break in that form is what we call shattering. Now, this other category called wood. Wood. What some of the properties of wood in reference here? Is wood strong? Some are strong, of course, depending on the type of wood, not so. Of course, brittlety is only, I mean ductility is to a metal. A wood can't be made into a wire. Elasticity, is the wood elastic? No, not really stiff. Can't resist bending. Yes, wood is stiff. Some can be bent, of course, but most are what? Are stiff. Brittlety is to glass and the other materials which can break down without bending. So now, leaving alone these categories, we are shifting very fast to polymers. 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 What's a polymer? Does that word look on you? Polymers. Does that word look on you? Polymers it comes from the word poly. Poly means what? Many. A polymer. So a polymer is a substance that is made from many other small substances. Many smaller substances. Now, we shall categorize here. We shall be a bit more specific to define a polymer. See? Then we shall look at types of polymers and their examples. See? Types of polymers and examples. Then uses of those polymers. Now, we have said a polymer is that substance or material that is made from very many small substances. Smaller substances. Now, a polymer is made from small substances called monomers. That within a polymer there are smaller substances. Now, when we attach the word poly to any material, you will know that that's a polymer. Like when you say polyethylene, which you call a polyethylene bag, not so? A polyethylene bag, that qualifies it to be a polymer, not so? Now, have you captured the definition of a polymer? He said it's a substance made from very many smaller substances which have been joined repeatedly. See, repeatedly. And the small substances are called monomers. Clear? Clear? Are called monomers. Now listen. The monomers, the small substances on Earth which makes special compounds called polymers have basically three major elements. Listen, we are saying that a polymer is made from small substances called monomers. The small substances on Earth have three major small elements that make up them. Now, within the monomers have carbon in them. There is something called carbon in them. They also have oxygen. They also have hydrogen. Some few have some nitrogen in them. These are elements that make up a monomer. Now, polymer is made from small substances called monomers. Monomers have smaller other elements in them or particles in them called oxygen, carbon, and hydrogen and nitrogen. Now, let us look at the types of polymers to be able to understand what we mean by monomers very well. Types of polymers and their examples here as we close down, as we summarize to the end. Types of polymers. Now we have those that are natural polymers, and we have those that are artificial polymers. Artificial polymers. Artificial polymers. Now, natural polymers and artificial. I will start with artificial polymers, then come back to natural later. Now, I will start with the first one. Artificial. To be artificial is to be man-made or made in the industry. The other word for artificial is synthetic. That the polymer is a synthetic polymer. To be synthetic is to be artificial. Another word for artificial is synthetic. Now, the common polymer that we have is the polyethylene. This is what we call a polyethylene bag. Clear? Now, this polymer here, when we say poly, then ethylene, the whole compound, the whole substance here is a polymer, but this smaller part that is attached to it is the building block of that polymer. That means the polyethylene is made from monomers, from small substances called ethylene substances. Patients, are you picking that? that a polymer, the building blocks of polyethylene are now called ethene. Now, we said ethene makes what we call a polyethylene. Okay, that's understood. What are the uses of polyethylene? As Polo give us one use there.
Used for making those packaging bags or polyethylene bags.
Yes, making polyethylene bags or packaging what? Bags. Okay. Don't you have some common plastics there? Polyethylene packaging bags similar in that same category? Yes, Patience? What?
Just for making those, let me say, there are those polythenes that are put on buildings when they are still on foundation.
They are used to make those, how do you call those what? Those polyethylene sheets for laying foundations of houses. Yeah. Now you pick that tin, that water bottle. That water bottle is also made of polyethylene. That water bottle, lift it up, Juko, is also made of polyethylene. That polyethylene makes us packaging bags, makes us water bottles, not so? Even some water pipes. Now, some other examples here, we shall give a few. We have also what we call nylon. Nylon. What's the word of nylon? Yes, Patience, give us some nylon. Where did you find nylon? In clothes. That means nylon is used to make clothes. What other? I would think that some are very many. Now I will leave very many for you. Do you have some for us? Polythene. There is one for making mattresses here. Polyurethane. For making mattresses, polyurethane. Clear? That means there are so many, but we can just have a few. Polyester, we can have terylene. This one is for making polythene. We've seen packaging bags and water bottles, water pipes, nylon making clothes, making carpets. Making carpets like carpets that act as that are placed in houses. Fishing nets. That means nylon can make fishing nets for you, for fishing, those who fish. Polyurethane makes mattresses. Polyurethane for mattresses. Polyester has the same uses as its friend down here. These are used for making curtains, making also clothes, making also carpets. So many things under those. We are now shifting very fast to our natural polymers here. They may seem obvious, but we don't know them. We have starch. Now, from this first example, what are some examples of natural polymers? Starch, yes, Asporo? Proteins. As long as you know the building blocks. What are the building blocks of proteins? Amino acids. That's from biology. That means proteins, natural. What else is? Lipids. We have the so-called Cellulose. Cellulose. What is cellulose? Cellulose is very, very important. And you have one on your body called keratin.
What about natural rubber?
Natural rubber, yes. Natural rubber. Now, scanning through the uses here, keratin makes what on your bodies? Fingernails and hair. Thank you. Natural rubber has many uses, like, let me have one use of natural rubber. Rubber, basically, what is the use of rubber? Making? Not clear. Making? Erasers. Erasers for rubbing. What of you have some butter shoes there? You can see some shoes, they are made of rubber, butter. Making shoe soles, so many of them, not so? These ones is what is your food. Even, yes, tires are made of that. Now, there are special materials here that we call fibers. As we try to close, let us engage in what we call fibers. Yeah. Fibers. Now you have some sweaters there. If you have a sweater. Yeah. It means now we are picking what makes some of these sweaters. That material called a fiber. Now, what makes to be fibrous is to have threads. To have kind of, if you pull out, you will see that it's just threads which have been put together. So many threads. So many threads that have been put what? Together. That's a fiber. Sweaters are made from fibers, and we shall see the types of fibers that are making us those sweaters. Now, a fiber is that material that can be made into a thread. Now, fibers are also divided into two types. We have those that are artificial, that are made by man, artificial. Then we have those that are natural fibers. But then natural fibers here are some are got from what? Animals. Some are got from plants, while some are got from minerals. You see? Yeah. That fibers are either artificial or natural. Artificial are made by man. Now, any material that has thread-like structures, like we saw polyester for making clothes. Clothes is some kind of thread-like. Terylene, polyester, nylon, all these are making clothes. That means under here, since they have threads in them, have nylon, polyester, any material characterized by threads, that's a fiber. So, animals give us, somebody has some information here? Some fiber from animals? Yes, speak louder, patience. Wool, yes. Wool, that's right. What else? Which fibers are from animals? Let me. Huh? Yes. Huh? Skin. Think for us. As we think about also this. I've put for you this asbestos. What do plants give us? What do animals give us? Plants give us cotton. What else? Silk. Yeah, silk. And all these are used to make clothes. So, give us this. Which other natural fiber do animals give us? Only wool? Animal? Patience, you are guessing. Now, as we close down our lesson, let us try to summarize through what we have been discussed. Want to give you have more? Or you have a question? Yes. Yes, speak louder.
I thought that silk
is from
silkworms.
silkworms.
Yes.
And there are worms called the silkworms. Explain further. You thought?
I thought silkworms. There are some worms that are booted. For that purpose, and they can produce threads or silk. They produce those threads when they are processed milk.
Okay. That means you are telling us, you are correcting us that that silk is from silkworms. Have you explained to us very well those silkworms? Yes, Patience, explain. What are silkworms? What are those?
Silkworms, they are like worms. Okay, it's like, if you look at it, you might think it's some kind of, or maybe a caterpillar, something like that. But it doesn't have those freaking things. And for it, whenever it's moving, okay, even though it's stationary, it produces some kind of, some substance, and that is so created to make threads.
Thank you very much, Patience, for being very clear with the Juko. Now, that means animals will give us wool and silk.
Yes.
Clear? Then plants will give us cotton and sisal, etc. Clear? Yeah. Now that's the end of our discussion of using materials. Thank you for being a very good class that is very informed. We discussed through the first subtopic under here was we saw common materials that are found around us, and you gave us so many. You gave us chairs, you gave us pens, you gave us very many materials. Then we had to categorize those materials in various categories of either they plastic, or they are wood, or they are ceramics, or they are metals. Now also from the various categories we discuss each type of material, how it is made. Like we said, concrete is from sand, clay, sand, cement, smaller stones which are called gravel, and water. Then we gave some uses of those different materials. We gave uses of clay, uses of glass, etc., etc. Now it brought us to types of polymers, which we categorized the natural polymers and artificial polymers. And under natural polymers we saw starch, proteins, etc. Then under artificial polymers we saw polyethylene, nylon, so many man-made polymers. Then finally we came to fibers, and we say the fibers can be categorized into artificial and natural. Then we saw artificial polymers, nylon, polyester, any thread-like material would qualify to be a fiber. Then under natural fibers we saw that natural fibers can be from animals, can be from plants, can be from minerals. And we saw from animals, we saw wool. Patience and Juko explained that animals give us silk. Then we saw plants giving us cotton and sisal. Now by the end of this lesson I'm giving you an activity of integration here, and I would request you to put it down. Activity of integration. Activity of integration. Now, instead of the activity of integration, let me give you some practice questions. We shall give the activity in the next session. The first practice question is, describe how you could improve your home. Describe how you could improve your home to make it cooler in a dry season. To make it cooler in a dry season and warmer in the wet season. And warmer in a wet season. Give reasons for your suggestions. Give reasons for your suggestions. Let me just give you two questions here. Number 2, plastics, metals, and ceramics are very important. Plastics, metals, and ceramics are very important and useful materials. Select one of them and describe. Select one of them and describe how life would be if the material that you have selected is no longer available. No longer available. Thank you for the lesson. We meet in the next lesson.